Hello and welcome to my first ever Twitch stream. This is Advent of Code 2022, and as you've noticed, it's not December now, so we're just doing the preparations today, which will include signing up for Advent of Code and getting our ID set up. And yeah, follow me on that if you're interested. So the way Advent of Code works is you have to submit solutions to 25 different puzzles, which each has on its own two levels. The first one usually is the easier part, and the second one is where there are some additional requirements or larger puzzles that require more efficient algorithms. In general, the puzzles get harder from each day on, but sometimes also, yeah, and a follow-up day is a little bit more relaxing than the day before. Each day at midnight in Eastern Standard Time, the puzzle is released, and a lot of programmers all around the world try to be the fastest. Obviously, there are a lot of programmers out there, and it's pretty hard to get a very good position. But yeah, there is a chance, and also it's a lot of fun without being on the leaderboard. You might already seen the Advent of Code website. I opened it here. It's a pretty cool and simple page. And for login, you'll need to do this via a third party with that offer authentication services like GitHub, Google, Twitter, and Reddit. As we're programming and we'll most probably put all our stuff on Git anyhow, we can use GitHub for that. That means you can click the GitHub button here, and you'll then have to sign in with your GitHub account. For me, this now automatically happened because I already signed up for it and connected my GitHub account. But in case you have not done this, we'll take a look on that as well. So let's open GitHub in a tab where I'm not signed in. And you can easily create your own account on GitHub by hitting the sign in button and then hitting the create an account. This point is at myemail.com. Continue, create a password, and then soon you'll be able to set up your GitHub account. Maybe you need to set up a second factor authentication by your cell phone or something like that, but that should also be easily doable. If you have finished that process, you should also be able to sign in to Advent of Code via your GitHub account. We'll ask you for permission of using your username, and which you will need to grant access to. And after that, you're happy signed in to Advent of Code, and you're all set up for taking part in the competition. As the title of my stream and my description, I'm going to do it in Kotlin. Kotlin is a programming language developed by JetBrains. It's also now the native language for Android app development, and it runs on the JVM, and yeah, also has some similarities to Java, but just prefer the syntax a bit more, and that's why I'm going to do it in Kotlin. So for Kotlin, you need all the tools that you need, like for developing Java. Additionally, you need the Kotlin compiler, and setting this up is actually pretty easy. You anyhow want to use a development environment and think the best or most common used or most liked, I guess, is IntelliJ. IntelliJ is an IDE, also from JetBrains. Used to be a Java IDE, and now, or since a lot of years, is also a Kotlin IDE, um, and has very nice UI and pretty good auto completion, and will also get you set up very easily. As with all JVM-based languages, you'll need to install a Java version. That's also something that IntelliJ will notch you to when installing the software. If you've got that set up, we are about to create our first project, or the first Advent of Code project. Therefore, we'll just navigate to or switch over to IntelliJ and EOC, I think. And then we have 2022. We'll choose that folder and we choose AOC 2022. Now, we want to create the Git repository. We also want to use Kotlin. We for now will use IntelliJ here. We might later want to switch to Gradle if we encounter any problems where we want to use a library, but for now, let's forget that. Just use Gradle, and we'll use it as the Kotlin DSL, and we'll also create the sample code. And for the group here, well, we could set something up. Just leave it like it is. And then we hit the create button. And we want to open this. So we've now already created our project. We can see we've got the folder structure here. We have Gradle, which for now we can just leave it. We have our source folder, main and test, with a Kotlin folder each. And we also have our Hello World application in here. Furthermore, the gitignore file, IntelliJ generates a lot of stuff already automatically. This is only files we just don't want to commit to Git because they are more, yes, not part of the source solution, and therefore we want to keep it out of that. And then we also have this build script here, where we already have our dependencies set up, and we can add later on add libraries to this dependency structure here in case we need them. Yeah. Other than that, we have our main application, and we now switch over to the Advent of Code website. And well, Advent of Code this year hasn't started, as I told you, but you can always take a look at the old examples from the years before and also use them for practicing. Oh, I'm not logged in, that's why I don't see anything here, but nevertheless, doesn't really matter. Yeah, and this is now how the examples looks like. Advent of Code is puts very much effort into having great story. It's usually about elves and elves helping Santa to bring the puzzles for kids, to bring gifts for kids, and you'll usually get an explanation on how this works. Then usually there is the first example. Its input is always given to you as text, and you can then expect an explanation for an example, and you can get also the solution for the example. and how many measures are larger than the previous measurement. This is your target. So we'll need to calculate this number, and we will log in for this, and we'll switch there. And then you see, if you have not solved it before, you now here have the possibility to submit an answer. And if this answer is correct, you will get your first golden star, and you will now have the option, you know, now see part 2 here. And then you have to submit your solution to part 2 here. And if you're done with that, you have your 2 golden stars. This is the first example, has been the first example of last year, so it's relatively easy. And yeah. For submitting solutions, Advent of Code lets you submit, I think, an infinite number of solutions, but it will not let you submit them very fast. So you can, I think, the first two or three solutions you can submit immediately. After that, you need to expect some delay. So Advent of Code will not let you submit solutions for, let's say, 1 minute, 2 minutes, or something like that. So they just want to prevent guessing on those examples. I'm pretty sure that for 90%, for most of puzzles, you will get the example is the same for every player, but the data you get will be different for all other players. And I'm pretty sure for all of the examples. Maybe there was one where all got the same. I'm unsure, but yeah. Yeah. So far we're good, I think, with the preliminaries. What we now can do is we'll now hop over to our development environment, and we will set up our we'll set up our data structure or our file structure, rather rather file structure, to have it easy during the Advent of Code time to manage the different levels, to run our program, and so we have also have an easy time to commit to Git, and yeah. So I will now create a folder here. Let's call it. We'll just call it our days puzzles. Let's call it puzzles. And inside of there, we create a new folder. It's called 01. And we create a new file. It's example. Let's call it example.in. We'll add it to our Git. Create a new file, example.out. So we can now go here, can grab our, for example, suppose you have the following report. This is the example report. We'll now copy that into the input file. And we have Uh, we have the example output. The puzzle answer was this, but the example output is 7, which we'll put here. And then, yeah, let's rename this example 1, and let's rename this as well example 1. And then we have another file, my one. So because I told you we have 2 levels, and because of this, I decided to split the examples the same way. So example 1 will be the example for the first part, and example 2 will then be the example for the second part. So if we then, yeah, we'll have filtered up, that's fine. And we can now also get our input. Our input is no previous, no increase. Can it be that you can't get the input if you have already completed the puzzle? Ah, okay. If it is like this, then let's check out our creative code repository from last year. Dem. Why is it called 12? That's a good question. And where do we parse this stuff? I did it this. Well, I did it this way. Yeah. So this was the TypeScript solution from last year. Or this wasn't the solution, but yeah, then we can create here. I would say a new Kotlin file. We call it puzzle01 kt add, create a function which is solve 0, 1, solve 1. We don't have any parameters, just run it, and we can create the same for 2. And we can get the file. We get the file from puzzles01, and we take example 1.in.readlines. So we just, I'm not absolutely sure about this path, but we'll see. And we'll call it lines. Then we need to do some computations. And afterwards, we want to have file should be So you can see we are just using the example here. We will parameterize this afterwards, but for now, write text, I guess, solution, which we haven't solved now, val solution, um, and would, yes, solution, val solution is gleich solution. This obviously doesn't really make sense for now. What also doesn't make sense is that we called this one out because we want to write this and afterwards compare it to to what we have. So for now, I actually would rename it to check because for the example, we know what the solution should be, but we want to check it against our algorithm to see if we get to the same example solution. Otherwise, we'll most probably need to fix our algorithm. So this obviously doesn't make sense. So let's start implementing the first example of last year's. So let's read. Let's read the interesting part. So as the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report, some numbers. This report indicates that scanning outward from the submarine, the sonar swept found depth from 199, 200, and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the numbers of times a depth measurement increases from the previous measurements. There is no measurement before the first measurement. In the example above, the changes are as follows. So we just need to count whenever we have an increase, and 200, so we should not count the first one. Then we need to count the 200 because it's more. 208 is also larger. 210 is also larger than 208, so we get another increase. And then we have a 200, which is a decrease, so we don't count it. But now we have 207 and we count it. So spot here. What you spot here is that we'll really always need to check against the last measurement. So there is no maximum. So for example, the 210 here also needs to, although it's more than the 207, we still count it because with the 200 in there, right? So this is just the detail. And we can just implement that now. And so what I have already wrote here as code is we take the file, we read all the lines, and then we send our lines to the variable lines, which is a list of string. We'll now want to iterate over this, and we want to determine how often we get an increase, right? I think in Kotlin there's something like the reduce function that seems like it could make sense here with an external counter maybe, but would rather actually like to use something like the zip function with offsetting the two lists. I actually would really want to try that. Yeah. Now let's do a simple regular solution first. So we make our increase counter or counter. Now let's just call it counter. Set it to 0, and after that we iterate over line in lines, and if our line parse line int to int is, we also need to keep track of the last measurement, so we call it last depth. I'm not really good in spelling, so yeah, obviously. The last one, and let's say we start with -1, so we have a pretty good chart. So, and if the line, or we can call it current, makes more sense, current depth, is there something in there that we, yeah, I would say we expect positive numbers, so with -1 we should be fine. Although we shouldn't count it, but we can always count it and then subtract the 1. So if the current depth is larger than the last one, then we want to increase our counter. Sorry, counter plus plus. I used to hit Control Alt L for auto formatting. So if that's what you get to see here. So, and actually, as we know that the start value will be higher, we can just already use this here. And what we are not allowed to forget, we are not allowed to forget to update this with the current depth. And our solution then will be the counter, and we'll put it to string. And we then write it to this output here. To see if this kind of works, and we'll get the, we'll just let it puzzle 1, solve. Yeah, should this be an object? Doesn't make sense. We'll figure that out later. Blah blah blah. We just for now create it as an object and run the solve 1. And now here's the Gradle compiling our Kotlin. We now ran the program, and don't we see anything here? Yeah, let's say there's a debugger. Not really sure if we got this stuff here right. Line, that actually looks good. Puzzles 01. I'm not sure if I need to create this somehow. Let's just check in the internet, because otherwise I think we should have gotten it. Or maybe we just need to update here. Maybe it doesn't reload from disk. Yeah, okay. It's 5, but our example outstates it should be 7. So what did we do wrong? Our last step is smaller than the last one, than this one here. We actually increase that one, and we get 10 lines, right? Yes, these are 10 lines. Let's just hop over to the Advent of Code page and check. This one is not counted. We'll count it, but we'll decrease for it, and then we have three. Yeah. This is the mistake we're doing. I will need to do that anyhow. So I now I actually just implemented whatever I said I should not do. So be smarter than me. Let's run it again. But we have another chance of checking if we actually get an update here. And now we got the 7, which is awesome. Then we have our input here. And we can now already see there is some room for improvement here. So, for example, we have to solve 1, we have to solve 2. We should maybe take this at least as a string. So I'll call this K. I'll create a file key. I call it that way. Maybe there is a bit of a name. And we'll use the file key. Yeah. It might actually be nicer if we already do the reading and the writing. Because it's anyhow gonna be the string and don't need to have this logic here actually. So I would now change this to call, let's call this, yeah, let's put something out here. This is, if you use Control Shift Alt M, you can extract a method, and we want to extract it to this scope, and I'll just call it read line file. Nah. I would say we have to solve here. Not super happy with this. Let's do something else. We'll create an abstract class to handle this. And we create the puzzle class. Puzzle. And it will get our 2 methods here. And we'll also puzzle, call this abstract class. And we actually want both of the solve methods to take in a list of string, we'll call that lines, and we want it to return a string. Yeah. And the output usually is just 1 line, so we'll keep it with a string. And we want to have that for this one as well. Then for now, I would say we can create a constructor for it. We'll call it level, and we'll make it a string. It's technically more or less a number, but we'll make it a string. And then we'll also keep track of that. And we create 2 properties in here. 2 properties should be. We have to solve 1, we have to solve 2. Change this. And yeah, let's call it run 1, run 2 for run 1, run 2, run 1, run 2, and example 2, example 1, example 2. And we can now use the multi-line edit. We hit the Alt key and drag with the mouse there. And we can then write fun. And let's just create them. And we'll have our examples here. So this then would be the level. Then we get the level path, get the base path, and the base path is a get. Base path get. I think it's like I think the syntax is like this, right? Get equals puzzles slash 01 puzzles slash plus level plus slash like this, and we can, because it's Kotlin, we can use the string interpolation level slash, which is a bit nice to read. And for the example, then we will have a function that's read lines. Yeah, I mean, I would just for now inline this actually. $1 base path. Then you have yeah, we can use something other Kotlin here. We can use yeah, we can just create a data class for this. So I would now so we have this solve one here, and we now have, let's call it solution. It's equal to this, or this is the input. Input is equal to this, and then we want to call the solve one, which is then returns with the input, returns our solution, and afterwards we want to write, and we want to write it to the output file. And this output file write text, and we'll want to write the solution to there. And we can now, we see we have these paths are actually, yeah, this path generation is pretty simple, similar. And therefore I would extract this here again and call it exam, call it run. Is it run? Is it part? I don't know, file. And we can put here the dollar file, and then we have the file extension for the rest. So I would now expect this to a method, call it read input. This is the read input, and do the same with this. Control Shift Alt M, and we want to put it to this object, and we'll call that write output. So then we have our solving method here. And this is basically what we do for what we want to put into the run, and we'll hand it over a file as a string here. And then we do the same for the run too. The only thing we change here is this, and we add a 1 here, a 2 here, and we add the 2 also here. So we can have it like this for run 1, and then we can remove that. We have our example 1, which is then basically just run 1 and example 1. Remove all of that, remove that. And we'll do it the same for the example 2. We don't need that here, we don't need that here. We just call it run 2. You can delete entire lines with hitting the Control key and the Y. And we'll now just move the output. Let's move the output here. And we can now check on our puzzle. We still have this part there. We can now remove this solve here. And head over to our puzzle. We don't want any implementation here actually. Which I think then requires us to call, no, how does it work? Yeah, I think abstract will solve this, and we'll just inherit from puzzle, and we can supply an argument here, and the argument is just say 1. So is not abstract and does not implement. Yeah, that's we're getting there. We have the lines here. That means that we'll have lines here, list of string, and we can basically throw away this one. And this is also no longer needed. We can have it as a return, but therefore we also change type of enclosing, and we need to make this override, and we need to add an implementation for this method, and we can trash this one. And if we now go to our main method, we can say .example1. Can now run this again. Just that we see that it actually does. That's nice. And we now can call it, we have to run 1. We don't really want to expose those, so we can make them private. And we have the examples here, and we should also do the same with the my. It's my, and this is my 1, and this is my 2. Pretty basic. And then we call it the my 1, and we run. I hit the debug, but do we care? And let's check if it did. Yes, it did. And this is the solution. I would now submit, and astonishing, it's correct. Yeah, for level 2, we would now create no, none of those files. What we now, what you see now here is we can easily, for the next level, we can switch it out in our main, and we can also just change this number here. And so we get the input passing. We can reuse this every day, and then, well, should have an easy time. Oh, so thanks for watching. I'll post this stuff on YouTube. I'll also try to link it from Twitch, and thanks for joining in. And um, we'll stream the first example. Bye bye.